we do the tutorial. Okay?
Okay.
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 Okay. So Kelvin, do you have class previously until 1:30?
No.
Or you guys still have time to had lunch lah, kan?
Oh, yeah.
I thought directly class since morning. Okay, so it's okay lah. Okay, so I will share my screen first. So, for today practical, wait I record the meeting first. Okay, so for today practical kan, we are directly go to lecture 7 because this lecture is needed for you to do your assignment letter. But the assignment still not given by KL because the course coordinator for this course is a lecturer from KL. So the assignment still not given. I think maybe it is in week 3 or above lah. Okay, because this week is already at the end kan. So we need to understand this, how to address data in memory and segment for you all to understand or to do the assignment letter. But I also still didn't see the assignment yet. But the course coordinator told me that this is needed for your practical or your assignment letter. Okay, so for this chapter, we will learn about the data storage sizes, the sizes that is usually used, and then what is the name of each of the sizes, and then the data addressing. So we will know what is the data addressing letter, and then the segmented memory management, and then after that, the program execution register. Okay, so I hope we can finish this 54 slides, and then I hope we can have the time to discuss our tutorial lah. But if not, we can discuss our tutorial. We discuss whatever we can first. After that, we will continue next week. Okay, so we proceed to our first subtopic, which is data storage sizes. So there are various names for the sizes in the data storage. Whatever we stored in the data, in the memory, if the data is saved as a 4-bit, 4-bit meaning 1, 2, 3, 4, 5, 4. So it is called nibble size. If your data is in 8-bit, so we call it as byte. So you remember kan, 1 byte is equal to 8-bit. So usually all of your character on your keyboard, your symbols, number, and either shift, FN, all of these characters, each of these character usually will be stored as 8-bit or 1 byte in the memory. Okay, so we also called word for the 16-bit. Okay, so double word for 32-bit, which means 4 byte, and then quad word for 64-bit, paragraph for 1 to 8-bit. Okay, so just remember that one lah. But I have provided a YouTube video here. I mean not me lah. It is the other expert. Okay, so if you want to know more, you can watch this video. Okay, so they will explain about the kilobyte, the megabyte, the gigabyte. Okay, so you can watch that to explore more. Okay, so for the data addressing, we proceed to the next subchapter, which is the data addressing. So this data addressing is actually the process of if you guys remember that in our computer, there's in our computer lah. In our computer, there's a component for input output, and then there's a component for memory, and then there's a component for processor, right? Microprocessor. So in that microprocessor, there's a register. Okay, so this register, if you guys remember in our class last time, fundamental of fundamental our last classes in our 20005 class, if I'm not mistaken. So we have already learned about the registers, meaning in the microprocessor, microprocessor, there's a ROM. That ROM is the small storage that we call as register. It store the temporary data. It is for the because of the speed of fetching of the data. So we have register for temporary storage data, and then the so the data addressing is, if you guys remember, each of the the process in the microprocessor or in our computer is there will be always the register will always fetch and submit the data to memory. The component that's responsible to store the data is memory. This memory here is referring to the RAM tu orang, random access memory. So the data addressing is the process of processing all of the data. I mean, all of the processed data in the microprocessor. If they want to store the data in the memory, they need to process the address. Meaning, we want to know, for example, this data, what is the address, what is its address when you will put it in the memory. Okay, so that is the process of data addressing, meaning the process of giving the address of the data to be saved into the memory. Okay, so this process have two procedure. Yes, so the process of giving the address of the data into memory have two procedure. First is Little Endian order, and then the second is Big Endian order. This Little Endian order, the meaning of this is, the procedure of this Little Endian order is, let's say you have 2 byte of data. 2 byte meaning 16 bit kan? Okay, so if you have 2 byte of data, and then the LSB meaning the less significant byte is stored. If you remember, less significant byte is at the rightmost, and then the most significant bit is at the leftmost. Leftmost. Okay, so for the Little Endian order procedure, it says that the LSB or the least, somebody is knocking my door. Beta. Okay, sorry. So the Little Endian order means that the less significant byte will be stored first in the memory. So, for example, this is the first memory, the first cell in the memory, because in the memory, each of one byte is stored in one cell. Okay, so because you have, for example, if you have 2 bytes of data, meaning to say that, for example, this one is the first cell in the memory, and then this is the second cell. So the less significant bit will be stored at the first memory address. Okay, so meaning you need to store this first. After that, baru you store this one in the second cell in the memory. So this is what we call as the procedure of little endian order. The other procedure is the big endian order, meaning to say that it will be the opposite of this one lah. Meaning to say that the most significant bit will be stored at the first memory address first. Okay, so this little endian order, first the LSB is stored at the first memory address, like I just described just now, and then the reverse byte sequence, meaning 2F here is the lower order byte, meaning the less significant punya byte. It will be stored at the low memory address, and then the MSB or the high order byte will be stored in the high memory address. So this is the high memory address. Okay, so I hope you guys understand. If you don't understand, you interrupt me lah. Okay, after that, we proceed to the segmented memory management. Okay, so real address mode. Okay, so this topic is telling about how we will segment or how we will divide the memory or the ROM. You imagine the ROM, sorry, not ROM, RAM, the memory. If I am saying memory, it is actually referring to RAM. Okay, so I have actually find a very good video explaining this, but I think you guys can watch later for better understanding. But it is some of the video is it is done or made by Indian. So you know kan dia punya slang itu a little bit hard for us to understand. For me lah, it's hard for me to understand the Indian punya slang. But don't worry, you can turn on the caption so you can understand what they are saying. And then their video is because they write what they said, so it makes us easier to understand what they said lah. Okay, so we proceed. So the segmented memory, there are 2 modes, meaning how you segment all of the memory, how you manage all of the segmented memory in that memory in RAM. There will be 2 modes. Okay, so for the first, we will learn about the real address mode, and then after that, we will learn about the protected mode. Okay, so the real mode is the way of the RAM operated. Okay, so if you guys see here at T2 at 6, this is actually the version of microprocessor that is one of the earliest version of microprocessor. Okay, so you guys have heard previously the first, the first working microprocessor is at T85, but that one is not stable. So the expert have come out with the T86. So it is the first microprocessor that is stable, and then it is used and expanded by the expert until we now have a microprocessor called macam i7. You know, right? Today's is the most advanced is the i7, if I'm not mistaken lah. Okay. So if you know, actually, the first version of the working microprocessor, we call them as T86. So, by using the T86, the expert have the microprocessor has have gone through the evolutions until first is the Pentium lah, and then until now i3, i5 until i7. So that the current processor that we are using in our computer is a very advanced punya, and that it is very hard to explain lah. So that's why in this subject we will teach about the 8086 punya microprocessor. This is the most basic of the microprocessor. So we will learn about how things happen in the microprocessor to how it operates. Okay, so this is the among the first version. So like I said just now, 8086 is the first microprocessor that is working and stable. After that, the expert has expanded to the 8088. Okay, so these two versions is only use the real mode operation. It operates in real mode. Okay, so the another version that is the latest than these versions are using either real mode or protected mode. Okay, so we will know what is the real mode and protected mode after this and how it operates. Okay, so real mode operations allows the microprocessor to address only the first 1 megabyte of the memory. Okay, so you remember the process of data addressing just now. It is the process of how you address or how you give address to your data to give the address of the memory to your data, so you can store your data in your memory. So this real mode operations, meaning it takes only the first 1 megabyte of the memory. Okay, so this is a very small punya data storage lah. So real mode is operate in only in the first megabyte of memory. Okay, so even in the version of Pentium 2 microprocessor, they're still using the this real mode operation lah. So the first 1 megabyte of the memory that is used by the microprocessor, we call them is the real memory system. Okay, remember the first 1 megabyte of the memory is the real memory system. So the DOS operating system requires the microprocessor to operate in the real mode. So you remember previously we have learned about the DOS operating system. It is actually different from the Windows operating system, because Windows operating system, it is operate in the protected mode, not the real mode. Okay, so just remember that the DOS operating system that we have learned previously, it is operated in the real mode, meaning it only use the first 1 megabyte of memory or of the RAM. Okay, so in all cases, each of these microprocessors begin operations in the real mode by default whenever power is applied or the microprocessor is reset. Okay, so each of the microprocessor usually memang by default they will operate in the real mode, meaning they will operate in the real mode first. Okay, so the purpose of real mode is to set up microprocessor into protected mode operations. Okay, so this is the purpose lah. Okay, so we proceed to the segment and addressing. Okay, so for the real address mode, the processor, all of the version of the processor that is start from the 86 punya processor can access this. This is 1 megabyte. all the microprocessor, x86 processor lah, we call this x86 version of processor, can access 1 megabyte of memory or of RAM by using 20-bit address in the range of 0 until this one. This is hexadecimal. FFFFF. So because we only can use 1 megabyte, so the memory is segmented, meaning it divided into 64 kilobyte each unit. So we call all of the segmented, we call each of the cell after we divided is a segment in the memory. So you guys can see in this next slide. Okay, so for example, this is your register, and then in the real mode you only can take up until 1 megabyte. So this is the highest range. If you remember just now, the range of the 1 megabyte is 0 until FFFD, and then you take 1 megabyte from the memory. So this is the highest, this is the lowest. Okay, so each of these is segmented into each of these cells. Each of these cells, which is 64 kilobyte unit. So each of these is 64 kilobyte, and then you map it into the 1 megabyte in the memory. So what is the addressing scheme? So the segment you know just now, the segment is the 64 byte. This one is segmented memory. So this one, each of these cell is segment. So addressing, what is addressing? So addressing is a scheme of how memory address is referred. So like I just said, so segment, meaning, yeah. So addressing scheme meaning is the scheme of how the memory address is referred, how the register refer the address in the memory, how the register give the address of your data to be put into the memory. Okay, so there are two methods of addressing. First is using the absolute address, meaning this is the physical address. This cannot be changed. It is static, meaning each of your RAM already has their punya own physical address. We don't know in what apply, but it has its own physical address. We call it as the absolute address. So this is referring the address that is predetermined in your memory. After that, using segment or offset address, meaning this is logical address. This is the address that is given to the segment that you created here. After that, you call it as the offset address. So this offset address is actually logical address for this segment. So this obsolete addressing, is the 20-bit value that directly refers a specific locations in the memory. Okay, so in your memory, like I said just now, so this is maybe the name of the memory. Each of these already have its own memory. So this is static. You cannot change because it is already defined before the system is installed. Like during the system is installed. Okay, so this is the physical memory. So remember that absolute addressing is the physical location in your RAM. So the offset address is the combination of starting address of a segment with offset value. So meaning to say that for this you have each of your segment, it also has its own logical address, and then after that you will combine it with the offset address. This offset address is just the macam index, macam who is the first one, second one, third one. Okay, so when we have this segment, we will combine it with the offset address, and then we will get the real address. Okay, so the segment address is stored in the segment register without last digit. Okay, so this segment address, it will be stored in the register in our microprocessor without the last digit. Because let's say you have 20 bit. This is the 20 bit of address. So the first 16 bit is stored in the register without its last nibble. Okay, without its last nibble. Okay, so this is the segment address. This segment address is stored in the register. In the register without the last digit. Okay, so the offset address, the distance in byte from the segment address to other location within the segment. Okay, so this is the distance between each of the segments. So if you have the distance, and then it will become the offset address for that segment. Okay, so offset address 16 bits ranges from this number to this number. Okay, so each segment can be up to 60 kilobyte in size. Okay, so we proceed to the 20-bit linear address calculation. So this calculation, it has the purpose to obtain the actual or absolute address of memory location from segment. So you are getting the actual or absolute address of the memory from the segment, meaning you have the segment and you can get the absolute address from the segment. Okay, so the way is, first convert the 16-bit segment address into the 20-bit address, meaning you just need to add the last nibble to the segment, to the 16-bit segment, and then you add the offset address. Okay, so the physical address is the combinations of the 16-bit segment address, which is the logical address, plus this one is the nibble, plus the offset address. So you can get the physical address. So this is the example of the calculations of the linear address. So suppose we have the variable hexadecimal segment offset. So this is your hexadecimal address. And then first we need to add, because it is only 16-bit, so we need to add another one nibble, because this is actually referring to, this should be 20-bit, but the segmented value just now, it is only stored in 16-bit. So we need to add another nibble, meaning 0 lah. 0, the nibble size of the 0 is 0, 0, 0, but because of this is the hexadecimal, so we just put 0 here. And then after that, we add the, let's say this is the offset address. So we add the offset address, and then baru we can get the absolute address. Okay. For the segments, So this segments is referring to the memory segments. So it is a special area in the RAM containing the code, data, and stack informations. So operating system use these segments to keep track of location of individual program segment. Okay, so there are three types, like we have just said just now, which is code, data, and stack segment. Okay, so just imagine that in the memory there are segments. There are three types of the segment in the memory. Okay, so the code segments will store or hold the machine instruction, and then the data segment will hold the program's defined data and constant. And then the stack segment will hold local function variable and functions parameter. Okay, don't worry if you don't understand this, because if we have time later, I will show the video. But if we don't have time later, then you guys can see the video later lah. So this segment is actually your code. For example, kan, when you have one program, you will have the variable, you will have the method, you will have the stack, you will have the array. So all of that code will be divided or categorized based on its category here. So each of the segment in the memory will hold all of that data into this segment based on its category. Okay, so this is the example of the segments in the memory. So segments can overlap in real mode addressing, meaning if the first segment did not fill up with the code or data up to 64 kilobyte, so another segment can be overridden on top of the existing segment for the unused memory space. Okay, so you guys can, if you remember that this is the memory of this is your memory, and your RAM, your RAM. Okay, so the first 1 megabyte of your RAM is operated in real mode. So in real mode, it means that your data can be overlapped. Each of the data here can be overlapped. It will be different in the protected mode later. Okay, so if your RAM has more than 1 megabyte, usually your RAM will be up until, if now our RAM can up until 16 kan, 16 gigabyte kan, but in the real mode it only takes up until this one, 1 megabyte. So all of your data in your RAM, all of your space in your RAM will be used by the protected mode operations later. So we will learn about the protected mode soon. Okay, so this is how you will initialize the data segment in the register using assembly language. This is just what introduction of how you can. This is the introduction of how assembly language will. This is the syntax of the assembly language that we will use later in your assignment. So, for example, when you want to code in assembly language, so you want to store numerical value, or you want to process a numerical value. Okay, so you want to process a numerical value. Your numerical value cannot be moved directly into segment register. For example, for example, you want to put just 1 nibble, or 1 nibble we can say this is 1 nibble data kan. Okay, so we want, for example, we want to put 1 nibble data in our memory, but at first it will need to process by the register first. And then after you change your one nibble data, because your nibble data is already in binary, kan? But although it is already in binary, you cannot directly store it in the memory, because it will need to go through two-step process first. First is this one. First, you need to move this data into the general register segment first. After that, this one is the syntax of the assembly language. So this is the location of the segment. Okay, so this is your data. So this syntax means that you want to move, this is the first process, first step. You want to move this data to AX. This is the location in the register. Okay, so you want to move this data into this location. So this location actually divided into two, which is AH and AL in the register. So the first step is you want to move first this data to this segment of register, and then after that, barulah we will need to put another, after that you move this data to this data, to this segment. This is also another segment in segment register. Okay, so why this is need to be move like that, kan? So it is actually a long story lah, but it is enough for you guys to know this syntax, meaning this is the location of the register. So this AX is equal to AH and AL. So this syntax means that you want to move this data into this location. And then the second step is you want to move this data that you stored in this segment to this location. So this is just a heads up about what is the assembly language lah. So what is the segment register? So it is a part of microprocessor that will generate the memory address. So I hope you are still not sleeping. I know this is a very technical and hard to understand. For me lah, kan? It is. I am in type of person that can learn more when I watch or listen. Okay, so I hope if you guys listen to or watch that video later, you guys can understand more lah. Okay, so now we proceed to the protected mode. Are you guys okay?
Okay.
Okay. Okay, so this is actually this protected mode and then real mode nih kan, it is actually a very large topic. There's a lot of technical things that you need to study lah if you are really into this topic later, if you want to major in this topic. But we cannot cover all in this chapter, so that's why we only cover what is the most important fact in each of these topics. Okay, so the protected mode, meaning that, so during the evolution of the microprocessor, the previous microprocessor or the previous basic microprocessor, which is the 80, 86, and 8088, they are using the real mode. But after that, the microprocessor evolved, and then there are various versions, and then they generate another way of the processor works. So they created another mode, which is protected mode. If previously the register can only use up until 1 megabyte of memory, so now we can use we can increase the memory that we use in the space that we use in the memory up until 4 GB. Okay, so this protected mode use so that to increase the use of linear address space up until 4 GB of addressable RAM. So we can use up until 4 GB the RAM space. Okay, so each program assign a memory partition which protected from other programs. So the programs are prevented from accessing each other memory. So if you guys remember just now the real mode, each of the data can be overlap each other, kan? But in the protected mode, your data cannot be overlapped. So that's why it is called as protected mode. So programs are prevented from accessing each other memory. So this mode is designed for multitasking, and then it is also supported by Linux and Microsoft Windows. So there are a feature of the protected mode. Okay, so you can watch this video later to make you more understand, because it is really good in explaining what is the protected mode. Okay, so but this protected mode, it operates differently with the real mode because it uses the segment descriptor table. Previously, we only use in the real mode, we only use segment address, which pointing the memory, the location of the memory directly. So in the registry, we have the segment address, which containing the address of the memory directly. But in the protected mode, it doesn't have that feature, meaning it doesn't have the segment address memory. But it is replaced by segment descriptor table. So this segment descriptor table is a table that listing all of the available or all of the address in the memory, because the memory that can be accessed using the protected mode is up until 4 GB. So it will list all of the cell it will list all of the address of the cell in up until 4 GB in this descriptor table. So in that video later, it will tell about what is the content inside this descriptor table. So the descriptor table, it has ada beberapa segmen. For example, if I'm not mistaken, there are 3, which is the address, and then the offset, and then the third partition or the third part of that table is it has the access mode punya status, meaning each of the cell it register the absolute address, the physical address, and the physical address, meaning the physical address, if you remember just now, it has the physical address or the absolute address and its offset, and then it add another information which is the access status, because we cannot overlap each of the cell to store the data. So that access status will tell either the cell is occupied by a data or not. So if the status is occupied, meaning another data cannot choose that address in memory. So that is the feature of protected mode. It doesn't have the segment address, because the segment address is directly will go to the 1 megabyte the data in the memory But this protected that mode, it has the descriptor table. to replace that segmented address previously in the real mode. So the program structure, meaning it also has the program structure, which is the code. I mean, each of the cell has the program structure that will store the code, data, and stack area. So all of your code will be divided into different category, and then it will be stored in each of its category here. So this is the category in that memory. Okay, so the CS, DS, SS is a descriptor segment. So this is the segment, the name of the segment in the memory that hold. So this one is code sector, code segment. This one is data segment. This is the stack segment. So all of that segment, this is the name of the segment. Okay, so this protected mode, it has the feature of global descriptor table, GDT. So this GDT, it has two types. So we will know what is the two types of global descriptor table. Okay, so MASM program use the Microsoft Flat Memory Model. Okay, so this MASM program is MASM is stand for Microsoft Macro Assembler. So this MASM program is actually the assembler for processor in version of 86 versions processor, microprocessor. So do you know what is assembler? Assembler is actually like a compiler. If you are doing coding, if you done coding, any coding previously, every time you finish your code, you will compile them, kan? So assembler is like a compiler, but assembler it is a program. It is also a computer program that works as a compiler, but it will compile the low-level language. So the low-level language here is the assembly language. The compiler, it will compile the higher level programming language. For example, your PHP all of the programming language that we learned previously, it is called as the higher level programming language. So because we are learning assembly language later, so we will use MASM program to compile our code in the assembly language. So this compiler or assembler is using Microsoft Flat Memory Model. So we will learn about this flat memory model in the next slide. Okay, so this is the flat segment model that is used by the MASM program. So this flat segment model meaning that it uses single global descriptor table, means that all of the segment map into entire 32-bit address space. Okay, so this is your this is your RAM or your memory, and then this is the segment in your register. Okay, so all of the address here will be stored in this 32-bit address space. Another model is multi-segment model. So the difference is each program has local descriptor table, meaning each of these has its own space in the RAM or in the memory. So our program letter will use the flat memory model, meaning it will use this one. Okay, so it will use this one. So we will I think we will understand this theory better when we do our code letter in assembly language. Okay, so program execution register. So we proceed to this program execution register. Okay, so actually kan in your microprocessor there will be a register, or there will be a part of your microprocessor that will do execution, because microprocessor will have to fetch and to send the data to memory. So that will be handled by bus interface. But there's another interface in the microprocessor that only dia punya responsibility is to process or to execute whatever data that is fetched and that whatever the data that is fetched and sent to the memory. Okay, so we will learn about the register which responsible in execution of the data from memory. So you can watch this video also later to understand more, because they will provide some visual. Okay, so before we going to learn about the register that will execute all of the instruction from memory, so we will need to learn about this index first. So A is stand for accumulator, B for base, counter or code, data and extended flag. So this is all the, we will use all of this term in our next slide. Okay, so in register, okay, so this is just imagine there's a part in the memory called a register. So this register is the high speed storage location inside the CPU. This is not inside the memory, it is inside the CPU. So it can store information temporarily. Okay, so in the microprocessor version 8086, all of the register are 16-bit register, meaning this is the example of the register. So it will store all of the data in this segment. So each of this segment will hold 8 bit. This will hold 8 bit. So this is the general purpose. I mean, all of this register kan, it will be divided into different parts. Okay, so this is the we will learn all of the category of the part of this register in our next slide. Okay, so but each of these part will store 16-bit register. 8-bit here, 8-bit here. Okay, so we will learn about this is we call as general purpose register. So it can be accessed either in 8-bit or 16-bit. So either it will use the whole cell here or only part of the cell. That's why it says it can be accessed in 8-bit or 16-bit. Okay, so we will proceed to the part of this register. We will learn about the part of this register. Okay, so for the general category, general purpose register, so assume that we have the microprocessor that can store at 16 bits. Okay, so these 16 bits can have a general purpose register in two types. Okay, so if you are using, if it is in 16 bit, it will call that as AX. So AX consisting of AH and AL. BX is consisting of BH and BL. And then CX consisting of CH and CL. DX is consisting DH and DL. So this is AH and this is L. Sorry. AH, AL. AH, AL, BH, BL, CH, CL, CH, DH, DL. So this is the general purpose register. Okay, so another category of the part in the register is the pointer. The pointer will store a data in 16 bit. So it containing SP, BP, and IP. So this pointer is this one. This is a part of in the register that is categorized as pointer. Okay, so after that, index. There are a part of register that we call as index. So this index also hold data in 16 bit. So dia punya name is SINDI. SINDI. This one, SINDI. This is the pointer. Sorry, this is the index. And then the SP and BP is the pointer. SP and BP is the pointer. And then the SINDI is the index. Okay, so the segment, we will have this segment. There's another part of register that we called as segment. So that segment consisting of 4 register or 4 cell, which is CS, DS, SS, and ES. This one. Okay, so now we are only learning about each part of the register. So we will learn what is the function of each of this register or each of that cell or segment in our next slide. Okay, so the flag, the segment or cell that fall under flag category is this one. So CF, AF. So there will be actually so they didn't show where the flag is, but the flag is actually here. So the general purpose register, it is purposely used to optimize the speed. So this general flag register, it is used for optimize the speed. And then it is used primarily for arithmetic and data movement. So we will use, or the microprocessor will use this segment to optimize the speed and then to use for the arithmetic and data movement. So in the 32-bit, because there are microprocessor that is in 32-bit, and then there are also in the 64-bit like we are using now. But for the XT86, it used 16-bit. So this one is used by the previous Windows. So the name is a little bit different lah when you are using the when you are using different bit. So for example, if it is in 16 bit, we will use the previous name lah. This one, the previous name for the 16 bit. But if it is in 32 bit, there will be the name is a little bit different lah. This is extended AX, extended BX, extended CX, meaning it extend each of the general purpose segment. Okay, so this is the general purpose register. So for example, this AX is the name for the, if you are using 16 bits. So this 16 bits consisting of AH and AL, but in the 32 bits, it is called as EAX. So the general purpose register in 16 bits is called as AX. So in 32, it is called as EAX, meaning extended AX. Okay, so this general purpose register, let's say in the 16 bit, you will divide, you will separate the bit. If you have 16 bit, so you will separate it in AH and AL. So in AH, you will store the MSB, so or most significant bit. And then in the AL, you will store the LSB, the least significant bit. So together, all of this, you call it as AX. So this general purpose register, it is used for different functions. For example, so this one will indicate what the use of that register. For example, A, it is used for accumulative register. B, it is used for base register. C is used for count register, and D will be register the data. So EAX, yes, also EAX, which is the accumulator register. So it is used for operation involving input and output and mostly arithmetic. So AX is automatically used by multiplication and division instructions. Okay, so for EBX, which is the best register. So the only general purpose register that can be used as an index to extend the addressing. So it is not involved in the arithmetic. It is only used as an index, meaning to number the segments. Okay, so it is used for computation and can also be combined with DI and SI as the best register for special addressing. Okay, so for the C is count register. Okay, so this count register contain a value to control the number of times a loop is repeated, and then contain a value to shift bits left or right, and then it is also used for computation. And then for D, which is the data, it will be used for input and output operation, and then it will be involved in multiply and divide operation that involves large value. So this is, of course, we only know the theory now. I know it is hard to understand by the theory, but we will, I hope we will more understand if we are learning more in our next lecture. Okay, so we proceed to another category of register, which is the index register and base register. So this index register is used for index addressing. It will hold the offset address, and it will associate with other base register. So there will be the index register. There will be a 2, which is the SI, source index, and then the DI, which is the index destination index register. So this SI will tell the index or the address of the source in the register, and then the DINE, it will tell the address of the destination of your, it will tell the index of the address in the memory, the destination of that data. Okay, so we call it as the ESI for 32-bit. Each of the 32-bit memang akan ada nama E because it is stand for extended SI, extended data index, and then this like there are another two lah, but this one are not discussed. These two are not discussed in this chapter. Okay, so the index register, this is the source, and then this is the destination. Okay, so this register required for some string or character handling operation. It is associated with the destination register. It is associated with DS register. DS register is in the general purpose register. It is not under this category. So the destination index, it is required for some string operation, and it will be associated with ES register, which is in the general purpose register. Okay, so guys, are you still there?
Yeah. Yeah. Very boring.
I hope. Yeah, of course, boring kan? Okay, so I think I will show you guys the video later after we finish this. Yes.
If this one got like coding kah?
Yeah, but this is only the theory, but the coding we will learn later. You will code, your assignment letter, you will need to code some coding using the assembly language.
Oh,
if you remember just now yang ada MOV, AX, MOV, DS, that one. We will learn that later. But okay, before we learn to code that, so this is some theory behind it lah. Okay, so we proceed to the pointer register. So this pointer register, there are 3. So it also have its own responsibility. So this IP is stand for instruction pointer register, and then the SP is stand for stack pointer. BP is base pointer. So all of this register called the offset address and associate with other base register. So all of this will call the information of the offset address. The offset address, if you remember just now, it is the index. It is the just a number of index, and it will associate with other base register, because to do the physical address, you need offset and base register kan. So this register will help to call the information of that offset address and the base register. So this IP, which is the instruction pointer, it is contain the offset address of the next instruction that is to execute. Okay, so it containing the offset address of the next instruction that is to execute that. So it also indicates the current instruction within the currently executing code segment. So for example, you have this segment address in the general purpose segment or register. So this is the address. And then this is the offset address that is stored in this IP. Okay, so the address for the next instruction will be this one. Okay, so meaning that this IP will hold the offset address of the next instruction, not the current instruction. So the computer know what is the address of the next instruction. Okay, so for the SP, it is referred to the current word being processed in the stack. So, so if previously the IP is holding the offset of the next instruction, but for the SP, it's hold the offset value of the current instruction. Okay, so the best for the current instruction will be stored in SS. If previously it is stored in CS. So now for the current instruction, it will be stored, the best for the current instruction will be stored in SS, but its offset will be stored in SP. So the current address, the current address will be stored in will this one lah. After it combine the SS, the base address in the SS, and then the offset address in SP. Okay, so for BP register, it facilitates referencing parameter which are data and address that a program pass via the stack. So it also can be combined with DI and SI as the best register for special addressing. Okay, we proceed to segment register. So this segment register is addressing an area of memory known as current segment. Okay, so this segment register is only addressing the memory, the area of the memory that is known as the current segment. So it stored the starting address of the particular segment. So all of that address is segmented to this different segment. So CS is the code segment register, DS is the data segment register, S is the stack segment register, and ES is the extra segment register. Okay, so each of these segment register will hold the data of this memory. That is known as the current segment. Okay, so this is the current segment. So this segment register will store about this. So each of these will be discussed or will be detailed in this next slide. Okay, so I think you guys can read about this.
We need to download program later.
Yeah, in your assignment. But yeah, but it is in the assembly language lah. But we will learn assembly language in our lecture at later. Yes, we will learn about assembly language later. But this is some of the theory that you will need to know lah. Although it is actually a little bit very theoretical. And if we didn't dig into deep, we may be a little bit, we can be confused lah. But yeah, because this topic is very broad. So just try to understand as much as you can lah. And then hopefully later in our In our next lecture, we will later can kasih sambung-sambung all of the info that we learn now. Okay, so flag register, I see first what is. Okay, so before we go into deep, because this is actually only telling about each of the part in the register and then what it do. But I think for this one, it's better if I show you guys that video first. This one. So that you are not ketidur. Because it is so theoretical. Okay, so I will share the link. Okay, so we watch this first. After that, we continue with the lecture.
Okay.
Okay.
So let's start with the protected mode memory addressing. In the previous tutorial, we have discussed the real mode memory addressing. So in this tutorial, we will see what are the benefits of using protected mode. Now in real mode, we know that the microprocessor will access or is restricted to access only the first 1 megabyte of memory space. In protected mode, in this mode, it allows the microprocessor to access all the data, and as well as some programs that are located above.
Don't forget to turn on your caption,
Okay.
because it will help you understand.
The first megabyte of memory. So unlike real mode, it can access the data and programs that are located above the first 1 megabyte of memory. Not only that, it can access as well as within the first 1 megabyte of memory. So it can also access the data and programs that are in the first 1 megabyte of the memory. So that's the first difference between the protected mode and real mode memory addressing. We know in memory addressing, the microprocessor tries to allocate or assigns the logical addresses to the memory space. In real mode, we have segment registers. So in real mode, in the segment registers, we have segment addresses, and these segment addresses are used by the microprocessor to access the memory. So in very simple words, the microprocessor can access the memory directly using these segment addresses stored in the segment registers. Now, segment registers are fixed. You cannot change the segment registers. So in protected mode, segment registers are there, but segment addresses are not there. So one major difference is that the segment address is no longer present
Guys, sorry, I give you the protected
this
mode punya
type of
video. So this is actually for the program execution video. Sorry So you watch the second link I give you lah first. The protected mode, later lah you watch. So watch this video first, the second.
Okay.
Students, let us continue with the internal architecture of 8086 microprocessor. In the previous video, I explained about the bus interface unit. Already I said the internal architecture is divided into two parts. So one is the bus interface unit and the next is the execution unit. So in the previous video, I explained about the bus interface unit. Now let us see what is the functions that are having this execution unit. What functions it can perform. So the execution unit, first it does it to tell bus interface unit where to fetch the instruction or data from. So where we have to get the data and to where we have to send the data, everything is told by the execution unit. To whom? To bus interface unit. So the execution unit is used to tell to the bus interface unit to where to fetch the instruction or data from. Okay. So next, to decode the instruction. So whatever the bus interface unit is fetch the instruction, that instruction is sent to the execution unit with the help of the instruction queue. After that, this execution unit will decode the instruction. To decode the instruction. Next, to execute the instruction. So whatever the instruction that is decoded, that instruction is executed by the execution unit. It execute the instruction. So after that, the execution unit contains the control circuit. It contains the control circuitry to perform various internal operations. So these are the functions. So now let us see the functional parts. What are the functional parts that are present in execution unit which does these functions? So the bus interface unit is, I already said, it's having three functional parts. So the three functional parts are the instruction pointer, which holds the next instruction to be executed, and segment registers. Next, instruction queue. So these are the three functional parts that are present in the bus interface unit. Now let us see the functional parts that are in the execution unit. The functional parts are, first is general purpose registers. It's having general purpose registers. You call it as GPRS, general purpose registers. And it's having the pointer and index registers. Whereas in bus interface unit, you are having the segment registers. But in execution unit, pointer and index registers. Arithmetic logic unit, which is the main device to perform all arithmetic and logical operations. Flag registers indicates the result of the data that will be indicated by the help of flag registers. Timing and control unit, which is used to monitor and control the operation of bus interface unit and the execution unit with the help of timing and control unit. So these are the five functional parts that are present in the execution unit. Now let us discuss one by one. So the first functional part is a general purpose register. So what is the role of the general purpose register that is present in 8086 microprocessor? General purpose registers. So actually 8086 microprocessor consists of 4 general purpose registers, that is of size 16-bit. So this 8086 microprocessor consisting of 4 general purpose registers, that is 16-bit. Each register is having 16-bit. So those are AX, BX, CX, DX. So these are the 4 16-bit registers that are present in, you call it as a general purpose register. We are used for general calculations, temporary registers, each of size 16-bit. Okay. So these can be divided into 2 8-bits. You can use these 16-bit registers as 2 8-bit registers like AH, AL, A higher order and lower order, BH, BL, CH, CL, DH, DL. So each is 8-bit and combinedly you can call it as AX, BX, CX, DX. So these are 8-bit registers and these are 16-bit registers. So that is the only difference. So 8086, these 4 you call it as a general purpose registers. Now coming to the next functional part, that is the pointer and index register. So what is the function of the pointer and an index register in the execution unit? 8086 has 2 pointers and 2 index register. So it's having 2 pointer registers and 2 index registers. So what are they? Those are the stack pointer and base pointer. Stack pointer and the base pointer. In the stack pointer, source indexed and destination index. Sorry, these are the 4 I'm talking about. Okay, a little bit confused. So it's having 2 pointer register. Those are the stack pointer and the base pointer, and the 2 index registers are source index and destination index. So SI is the source index, DI is the destination index, SP is the stack pointer, BP is the base pointer. Okay, so 8086 microprocessor is having stack pointer and base pointer, source index and destination index. Now let me explain about next functional part, that is ALU. So everyone knows about ALU. ALU is the arithmetic logic unit, which is, it is a 16-bit ALU, because 8086 is a 16-bit processor. That means that ALU is a 16-bit arithmetic logic unit, and it performs arithmetic and logical operations. It can perform arithmetic and logical operation 8-bit and as well as 16-bit. So it can perform 16-bit as well as 8-bit operations. So the 3 functional parts are over. Now coming to the next, that is a flag register. So this is one of the important one you have to be remember. This is a frequently asked question also. What is the role of the flag register in 8086 microprocessor? So actually 8086 microprocessor has 16-bit flag register. So this is a 16-bit flag register. 8086 microprocessor is a 16-bit flag register. Among this 16-bit trap, we use 9 flags and remaining as 6 flags are done. Means in this 16-bit, those are divided into 9 flags and 6 flags. 9 plus 6. Okay. So it is 60. Sorry. 9 plus and 6 is unused, 0 to 15. Okay, so in that only 9 flags we will 9 flags will be a trap we use for the 9 flags, and the remaining 6 flags are unused. So just remember that 6 flags are unused. So let me explain this. Among 9 flags, we divided into 2 categories. Okay, so actually 6 flags is unused, so that is means no operation will perform on the 6 flags. So only 8086, the result, the operation is stored in these 9 flags only. So again these 9 flags will be divided into 2 categories. So one is status flag and another is control flag. So all these 9 flags is divided into two categories, status flag and control flag. Okay. So altogether there are 6 status flags. 6 status flags and 3 control flags. So total 9 flags. 6 plus 3, 9 flags. So 9 flags are divided into 2 categories, status flags and control flags. 6 status flags and 3 control flags. So let me explain about the 6 status flags. So it is indicating the status of the result. So the status flags are carry flag, auxiliary carry flag, zero flag, sign flag, parity flag and overflow flag. So these are the 6 status flags, and 3 control flags are 3 control flags. So controlling the operation, the 3 control flags are direction flag, interrupt enable flag and trap flag. So these 3 flags indicating the control status and the 6 status flags indicating the result of the operation specified, the carry, whether the result is having the carry, whether the result is having the auxiliary carry, or you get all the zeros, whether the result is a sign or positive sign or the negative sign, and it is having the even parity or the odd parity, is anything overflow is there. So that indicates in status flag and control flag. So let me write that flag register. So I said this is 16-bit register, that is from 0 to 15, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. So this is the 0. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is a 16-bit flag register. So in that I said 6 are don't count, means unused flags. 1, 2, 3, 4 and 5, 6, sorry, total 7, because it is 16-bit register, 7 flags unused, okay, and the 9 flags used flags. So these are the unused flag. Then coming to what are the used flags. 11th bit is overflow flag, direction flag, interrupt enable flag, trap flag, sign flag, zero flag, auxiliary carry flag, AC, you better keep AC, auxiliary carry flag, parity flag and carry flag. So these are the different flag registers. So this is carry flag and this is parity flag and this is auxiliary carry flag and this is zero flag and this is sign flag. And coming to here, trap, interrupt enable, and this is direction flag, and this is overflow flag. Okay, so up to here, so these are all status flags. So 1, 2, 3, 4, 5, and this one is a also status flag. And these three you call it as the control flags. Okay, 6 status flags plus 3 control flags, total 9 flag registers are used, and the 7 flags are unused. So this is about the flag register, that is one of the functional part of the execution unit. Now coming to the last functional part that is present in execution unit is the timing and control unit. So what is the use of the timing and control unit? So I already said it is used, the control unit of execution unit directs all internal operations. It directs all internal operations and also responsible for generation of control signals. So that is the operation of this timing and control unit. So let's see this diagram, internal architecture. So I explained about the bus interface unit, that is the first part, and the second part is the execution unit. So this total execution unit is divided into 5 functional parts. So one is the general purpose. So these are the general purpose register, GPRS, general purpose registers. So each is 8-bit, total 16-bit. This is 8-bit registers, DH and DL, and completely you call it a 16-bit register. And these two are the stack pointers, and these two are the base pointers. Sorry, this is a stack pointer and base pointer, and these are the index registers. Okay, these are the pointer registers and these are the index register. Pointer registers are 2, stack pointer and base pointer, and the index registers are 2, source index and destination index. And coming to this arithmetic logic unit, which performs all the arithmetic and logical operations. And coming to this is a 16-bit flag register, 16-bit flag registers, which is having the operands like to store the data, like operands are carry flag, auxiliary carry, parity flag, zero flag, sign flag, trap flag, interrupt enabled, direction flag, overflow flag, like that. Okay, so this everything will done the operation here, and the result will send to the bus interface unit, and bus interface unit will send the result to the external parts, that is the memory and input output ports. And from where to get the data, that will be indicated by the execution unit, and that intimates to the bus interface unit. Then the bus interface unit will fetch the data from that particular location, which is directed by the execution unit. So this is about the internal architecture of 8086 microprocessor, and one of the important topic, you all have to be learn this architecture. Thank you. External location, and the bus interface unit will fetch the data from that particular location, which is directed
So,
by the execution.
guys, have you finished watching it?
The first one only.
Hmm?
The first video
Yeah, no, the second.
already.
Oh, okay. So I hope you can understand lah. I know dia punya slang itu a little bit hard to understand because because it is Indian tongue kan. Jadi it's a little bit hard to understand, but I hope you guys can understand it lah. Can kah?
A bit lah.
Yeah, a bit lah.
Kelvin?
Need to memorize all the position and then show
Yeah.
I know.
Yeah. Don't worry, but if later there's questions about that, So it is easy for you guys lah, because it is now it is open book kan. So if I think it will not ask about where is the position, what I think what it do mungkin lah, but the position, and then I am not sure lah, either it will ask you to create the diagram ka or not, but I think no lah, to create the diagram. It is just for you guys to understand before we go into the coding part itu. So yeah, this topic is a little bit not boring, because it is like that. Memang macam begitulah. Because we will need to imagine the things that we didn't see, and then we need to memorize the function, each of the part. So that video is already explaining all about this topic, the things that we don't understand just now. Each of the part, there's a general purpose register, the pointer register, segment register. All of this part is already told in that video kan. So I hope you guys later for the theory part you can refer to this this lecture lah. But if you want to see the diagram, I think the diagram just now showed by that professor is really useful lah, because in this lecture it didn't show the diagram kan, it didn't show the whole architecture, the whole execution unit architecture in one piece, so it is hard to imagine. But in that video just now, it shows all of the, it shows the diagram lah. So later I will upload this video, this lecture. I will update the lecture in our Google Classroom, because previously it doesn't have any link or comment. So what I put, all of the video link, it can help you guys to understand more, because I also learned from that. Because this lecture alone cannot explain much, because it is macam not too general lah. It is macam too general also lah, this lecture. So we need that video to understand more. So if you guys want to know more, you can check and open whatever YouTube link that I shared here, because it is really helpful lah. Because this topic is very broad. Memang susah mau faham. You need to read again and then watch another video to help us to understand more. Okay, so we have about 15 minutes. Do you guys already answer the questions, the tutorial questions?
Already.
Yeah.
Okay. So do you guys do you have any problem? You want to compare the answer?
Okay. Miss.
Yes.
My tutorial kan, I only put the answer saja.
You didn't show the step?
Got, but I type in a word.
Oh, yeah.
So a bit like I don't know, a bit messy lah.
You type in the word lah.
Yeah.
But you show the step in the word lah.
Yeah, I try to type it lah.
Okay. Okay, so okay, so first I will give the answer. No. Actually, for each of the question, I will give the answer, but I will not show the step. So we will compare your answer lah. If it is same, then okay, meaning we have the same step. But if it is different, then you guys need to see or I need to see your step first, how you get that figure.
Okay.
Okay, so
I don't know. Don't know what step. Don't know what step can get the marks, even though I know the answer.
oh, okay. So later I will show the step lah, so you can see how you can get marks from that step.
Okay.
Wait, I stop presenting first. Okay, guys. So for the questions one, the answer is okay. I will. Wait, I will share again my screen. Okay, so can you guys see my screen?
Yeah.
Can.
Yes. Okay. So do you have the same answer,
Yeah.
Yeah.
Kelvin?
Yeah.
Okay, so this one is easy lah kan, because we can just directly divide. The way is very easy. The way is we need to divide each of these into the nibble form, meaning 4 bit in one group, and then we compare with the hexadecimal number. So this one is easy. So you guys can see, if you guys all have this, then no problem. Okay, so for these questions, it should be this one. Do you have the same answer?
Yeah.
Can I
Yeah,
use the process of splitting them into two ones and zeros like that, like the above, like the 3
This
becomes
one?
0. Yeah.
This one?
Yeah. Use like that to get the answer.
So how?
Hey.
I mean, your answer is what? In decimal or in hexadecimal?
In decimal. In binary.
Oh yeah, sorry. Yeah, in binary.
You just change 3 into 0, 0, 1, 1, and then 7 become 0, 1, 1, 1. 0.
Oh, 0. You do it like that. Okay, so you are actually using the technique previously, which is the BCM kato. BCM, binary that one
Wrong.
Yeah, wrong.
Oh, oops.
That
yeah.
is,
Answer.
yeah, it is another technique, but for the conventional way, so you need to use the conventional way.
Oh, that only works for hexa. All right.
Yeah.
All right. My mistake.
Okay, so later you correct it lah. So when the questions asking to convert this decimal to binary number, just use the conventional way, which is like this. Unless the questions asking you using another technique, which is, for example, you use just now is BCM. I don't really remember BCM kata. Okay, so like just I said previously lah, if it doesn't specify what technique to be used, so just use the conventional way. Okay, so for this one, also okay. Do you have the same answer?
Yeah.
Oh, it's yeah, same.
Same. 113 because it is in best 3 kan, we didn't cover this, but it has the same concept. Dapat kan, Noel? Do you get this answer?
Yeah. Same.
Okay. Okay, so I hope you guys can better remember lah. Although it is decimal to base 3, and this base 3 we didn't cover previously, but it will have the same concept. So the same way can be used, or the same step can be used to calculate this kind of questions. Okay, so now this one also we didn't cover until base 5, but do you have the same answer? 89.
Yeah.
Yeah, Sam.
Okay, Noel?
Yeah. Same.
Okay, so we proceed lah. Okay, so for this one, Sam.
1361. Yeah, Sam.
Okay, so Noel?
Same.
Kelvin?
Yeah.
Okay. Okay, so this one also easy. The way is you just need to multiply each of the digit with its base with the position with its weightage positions. Okay, so do you guys have the same answer?
Yeah. So you need to show the steps also.
Yeah, this one also you need to show the step. So this is the step.
Yeah.
Okay, Farah?
Yeah, Sam.
Okay, so we proceed. For questions B?
983. Yeah, Sam.
Noel?
Yeah.
Kelvin?
Yeah.
Okay, so we proceed lah. Question C, 15728.
157. Okay. Yeah.
Okay. Noel?
Yeah. Same.
Kelvin?
Yeah.
Okay. So D, 48276.
4827. Okay.
Ngam.
Yeah.
Kelvin?
Yeah.
Okay. Don't be shy, yeah. If you have different question, different answer, kan? So just tell me if you have the different answer. Because previously, like Kelvin tu kan, it is not totally wrong, but it needs some clarification lah. Just like I said just now, because the question didn't specify what technique kan, so it is normal lah for Kelvin to think that technique also can be used, but that's why I said if the technique didn't specify to use any technique, so just use the conventional way. Okay, so question E, 61356.
Yeah.
Yeah, Sam.
Okay, Kelvin?
Yeah.
Okay. Okay, so for question F?
5658. Yeah, Sam.
Okay, Noel?
Yeah.
Kelvin?
Yeah.
Okay. So, we will discuss until question 3 sajalah because si Kelvin will have his tutorial, it's OQ kan. So we will discuss until question 3 lah. So convert all following hexadecimal numbers to binary number. Okay, so this one is easy lah kan. This one baru like you just compare what is from the table lah. You can say this one. Do you guys have the same answer?
Okay, Sam.
Yeah.
Okay, so Kelvin?
Yeah.
Okay, so this is the how we we convert the hexadecimal number to the binary number lah. So we just, yes.
This one not really have the step lah kan, just like convert it.
But actually you know the process behind it lah kan, because you know how this nibble can apa tu, resulting or can produce 5, because you know kan, each of these step, each of these apa, it will hold what weightage value. Okay, so I hope you guys understand. If you don't, then you can ask later lah. So for question B.
Question B. 01.
Oh yeah.
0111600. Okay. Yeah. Correct.
Okay. Kelvin? Okay.
Yeah.
Okay, so we stop at questions number 3 lah. So we will continue number 4 in our next replacement class.
Okay.
Or if we have time later in our lecture time, so we will discuss this lah. Okay, so if you don't have any questions, then we can end our sessions now.
Okay, Miss.
Okay, bye.
Okay, Miss.
Okay,
Thank
thank you.
you.
Okay, bye.